Hello, I am Kumar Deepak. I work in the data center group of Xilinx. Today I am going to demonstrate anti-money laundering watchlist management application run on Amazon AWS F1 instance. I will show loading of 6 million records of watchlist into FPGA memory, followed by running check on 100 banking transactions against this watchlist, and then I will present the results. The watchlist consists of 30 bank codes, around 9,500 names of the banks, 6 million names of the people, and 148 stop keywords. Let's get to running the demo. This window shows names of the banks who are in the watchlist. This window shows codes of the bank who are in the watchlist. This window shows stop keywords that we need to be looking for in each transaction. And this window shows names of the people in the watch list. These four data set comprises the watch list. Now this window shows 100 transactions that will be checking against that watch list. Each transaction has several fields. A subset of the fields of each banking transaction needs to be checked against the watch list. Some of the fields will be direct string matched, some will be substring matched, and some will be edit distance matched. Now let's get to running the demo. I've got a host code executable called test already built, and I've got the necessary XCL bin, which is the bit stream going on FPGA already built. And I'll provide this directory where my watch list is. And -C0H for running on FPGA, not running on CPU. So I'm going to run it. This is going to load the watch list in x86 memory, then send it to FPGA memory. Once that is sent, then for every transaction, data need not be resent again. It is not sent again. This transaction are just run. And then transaction running is very, very fast. As you can see, running each transaction took on average 8 milliseconds, which is very fast. The first transaction takes a little longer, 24 milliseconds, because some housekeeping needs to be done. And subsequent ones run very, very, very fast. Here, as you can see, OK means the transaction did not have any match against the watch list. KO means the transaction had a match against the watch list. So this transaction will be denied. Now, if I were to run the same transaction using only CPU, then it's going to be very slow. Using one core of CPU, I ran it just before starting this recording of the demo, and it took more than 5,000 milliseconds. Now let's compare the results. As you saw, FPGA is around 650x faster compared to one core of Intel Xeon E5. Now, if you were to add more cores and parallelize the application, you'll get some reduction, but Amdahl's law will kick in. In addition, the memory bandwidth to these multiple cores will become a problem. So after a while, we'll hit a wall and it won't go down. It will never get down to 8.5 milliseconds, which is needed for this kind of real-time banking transaction check. Thank you for watching the demo.